Let's take a brief look at nonlinear inequalities. First of all, let's consider this one, y greater than x squared. Now, if you think about just y equals x squared, that is this parabola right here. And I put it to be broken. The curve is broken instead of solid because this is y strictly greater than x squared. It's not greater than or equal to. So, but if you think about y equals x squared, what this represents is all the ordered pairs where the y is just the square of the x. So for example, 2, 4, 3, 9, and so forth. Those are points on here. Negative 3, 9, negative 4, 16. Those are points that are on this curve, y equals x squared. Well, when it says y greater than x squared, what we want to represent the region where all of the y's are bigger than the square of the x. And so if you look at the graph, this is where they're equal. Well, the y's being bigger would be above it. So that would be the shaded region here. So the way we would represent the solution to this, the way we would represent this statement here graphically is with this shading. We do a broken sketch of the y equals x squared, and it's broken, dashed because it's not equal to, and then we just shade above it. Okay? Now, let's think about this one. Here we want y less than 1 minus x squared. Okay? Now here is y equals 1 minus x squared. And we want below that. We want the ordered pairs where the y is less than that. So we're going to shade below like this. Now, if we wanted to put those together as a system, we simultaneously want the shading above this curve, see, y greater than x squared, and simultaneously below this one, y less than 1 minus x squared. So this means we're shading below, right? We want below this curve and above this curve. Well, if we put those two together, this is the solution region right here. Above this curve, below this curve, where they intersect is this part right in here. Okay? That's where they intersect. So if we were asked, sketch the solution region for this. Well, it's a shading. You sketch the y equals x squared. Since it's not equal to, you put a broken curve. Y equals 1 minus x squared, broken curve. And then you determine about the shading. Well, if it's y greater than x squared, you're going to shade above. You're looking for the y values bigger. And down here it says y less than, means you're going to shade below. So we've got this solution region right here. Now let's look at another one. Here we've got a circle, x squared plus y squared less than or equal to 1. And we've got y greater than or equal to x squared. So look, here's the deal. If we were to just sketch x squared plus y squared equals 1, we would have a circle. Okay, just a solid circle. But this says less than or equal to 1. Well, out here, outside the circle is where x squared plus y squared is greater than 1, all out here. Where it says less than, that means, look, the ordered pairs on this circle have this quality. If you square the x and square the y, add them together, you get 1. The points inside the circle have the quality that if you square the x, square the y, you get something less than 1. So this inequality is represented by the shading right here. Now, this y greater than or equal to x squared, well, it looks like this, see? So if we're talking about y equals x squared, that's this. But this is y greater than x squared, so it's above it. Now, if we put these two together, that would be the sketch of the solution region here. See, it's this part right here, above the parabola and inside the circle. You put those two things together and you get the solution region for this system.